my name is Mikhail. I'm a 16-year-old neurotech developer, and I'm working on taking control of our cognitive evolution by building the tools necessary to read and write our neural code. This November, I participated in the Poirier Solving the Impossible competition. This competition involved 5 finalists working on pitching their solutions to some of the world's biggest problems. The winner getting a $1 million trust fund in their name. The presentation went great, and I'm super excited for all of you to see it. Let's roll the clip. It was humanity's greatest jigsaw puzzle. Built up over evolutionary eons, it featured 46 spiraling ladder-like structures, 3 billion pieces, and took thousands of scientists working around the globe 13 years to complete. The Human Genome Project was an inward voyage of discovery, led by an international team of researchers looking to determine the sequence of all the 3 billion little puzzle pieces in our DNA. And it was all done on a machine that looks like this. It costed about $1 for each base, was super inefficient, and was overall just a very slow way of sequencing the genome. Fast forward 3 decades later, with the arrival of next generation sequencing technologies, we have drastically changed the way we sequence the genome by rapidly improving the status quo. So to give you an idea of what the difference in tools looks like, the Human Genome Project, 3 gigabases, 15 years, $4 billion. One run on a machine with next generation sequencing, on the other hand, 600 gigabases in 7 hours for $300. The Human Genome Project was a unique opportunity to empower millions of institutions to solve some of the world's biggest problems. It was a legacy project that will continue to light the way for several generations to come. As a neuroscience enthusiast, learning about how we put the puzzle pieces of our human genome together, it makes me wonder when we will start making strides in building the next jigsaw puzzle of our time, the jigsaw puzzle of our brain. I believe that we are about to enter into one of the most consequential revolutions in the history of the human race. Namely, because by putting the puzzle pieces together, we will understand the building blocks that make up our neural code. And so if you think about it, if we don't unravel this master code that allows us to interpret any neural activity at will, at stake will virtually be every radical advancement that we are able to imagine. For example, what if you could walk a mile in someone else's shoes? What if you understood my contextual framework? What if you understood my memories and my emotions? Would that change the way we deal with each other, the way we cooperate, the way we make decisions? Would that change our creative ability? What if instead of our enemies, we destroy the concept of enemies? And what if we increased the limitations of our biological brain and increase its bandwidth? I mean, these are really cool implications. The question is, why does the ability to read our neural code hold any importance in society? I want you to take a look at this graph. As you can see, as technology continues to grow at an exponential rate, our intelligence has remained stagnant. It is flatlined. We have gone from clubbing each other with stones to shooting each other with automatic weapons. And although technology hasn't surpassed the sum of human intelligence, if we don't act fast enough, it will pass us. So at what point in time do we look at the difference between the capability set of our technology and our own abilities and say we feel very uncomfortable? When I look at the world and try to assess who's investing in the brain, who's trying to improve its abilities, who's putting the capital, I am astonished. Why is the brain such a blind spot on our society? Yet everything we are, everything we build, and everything we aspire to become stems from the brain. I am in pursuit of devoting my life to the brain, specifically in regards to building the necessary tools to read and write our neural code. So what is the state of play? What can we do today? Well, we have the most common brain-computer interface modality, EEG. We have fMRIs, FNIRs, magnetoencephalography, etc., etc. But the problem with these neuroimaging modalities is that it paints only broad strokes of brain activity, like a series of satellite images over a hurricane that shows the storm moving, but not the formation and disruption of individual clouds. In general, these technologies lack the foundational power we need to read and write our neural code. And so ultimately, we are at the primitive stages of the Human Genome Project. This BCI in my hand is the equivalent to that of the sequencer in the 1990s. And so this is why I am committed to building the killer app of brain-computer interfaces by iterating on and improving functional ultrasound imaging modalities full stack, from the atom to the ML. The end goal being to take control over cognitive evolution by building the tools necessary to read and write our neural code. So, why take a chance on me? 2 years ago, a boy lost his grandmother after her 8-year journey with Alzheimer's. Growing up, it was devastating to watch someone he loved lose their humanhood right before his eyes. As an 8-year-old kid, he was always so curious as to what was happening. One day, she would remember his name, and the next, she wouldn't. It was as if a light in her brain had been shut off. She went from being someone who he knew to someone he didn't even recognize. What had gone wrong? This was the question he asked himself every single day. And so he fed his insatiable curiosity of the brain in order to understand the puzzle that was his grandmother's memory. And that little boy was none other than me. From reading the most complex neuroscience books I could get my hands on, to researching about various topics related to the brain, from free will to consciousness. From that point on, I was in constant pursuit of understanding and improving these complex systems. 2 years after my grandmother got the disease, I was empowered to convert my learnings and experiences over the years into action. And at the age of 10, I attempted to find a solution to Alzheimer's using CRISPR-Cas9. This project was recognized by the top engineering designer firm in the world, Worley Parsons, and I was granted the Engineers of Tomorrow Award. In my early teens, I continued to develop my breadth of knowledge about the brain. However, it wasn't until 1.5 years ago that I realized that in order for me to understand, interface with, and improve the brain, there must be a technological revolution. And that is what has brought me to stand in front of all of you today. My obsession and my passion for brain-computer interface. In the past year, within BCIs, I've created a proprietary 3-in-1 technology that can effectively diagnose, stimulate, and treat all brain disorders associated with the limbic system. I've created multiple white and academic papers related to BCIs. I've spoke at Canada's largest developer summit by IBM on brain-computer interface. I've built and coded 15 plus brain-computer interface projects ranging from rating interest in visual content using EEG to lie detection and more. I've built 3 projects in the head office of one of the top BCI companies, Neurable, using their new EEG headset, the N10. And I've also built an emotion classification messaging app for one of the top brain-computer interface companies, Emotive, in order to give voice to the voiceless. These are just a few critical milestones within my world of BCIs. And each one of these puzzle pieces portray the wide array of experiences of my life so far. And I'm thrilled to be sharing my journey with you. This is only the start. So join me as I take control of our cognitive evolution by building the tools necessary to read and write our neural code. Thank you.